Hello friends. Today we are going to see about some another topic in generative AI. In previous video, uh, we saw about RAG and the GraphDB. How does the GraphDB is very useful in RAG technique. These kind of things we previously saw. Today we are going to see about another concept that used in RAG, that is hybrid search. In RAG, hybrid search in RAG. Before, see about the hybrid search, how this hybrid search is working, and where and when it is useful. Before we going to see this, just recall the how the RAG technique working. For example, we have a document. So we need to train an LLM or give some knowledge so that it can mm, respond to the question that relevant to the content that present in this document. So the LLM need to answer the question that are present in the content present in the document. So to train this LLM, first we split this document into some junk files, into some small pieces. The small pieces is called chunks. For example, if this document consists of let's take an example. This document is consists of 100 lines. The first 25 lines is present in D1, the first chunk, and the second 25 data are present in second chunk. Like this, totally we split this 100 lines into 2020 split in 2022 chunks, and then this each chunks is converted into that each chunks present 25 lines. This datas this text datas are that present in each chunks are converted into numerical format by using some embedding technique. This text is converted into some numerical vector by using embedding technique. We already knew about what is embedding technique. Some examples of embedding technique is bag of word and word to vec and TF-IDF. These are some example of this embedding technique. There are so many embedding techniques are there. Depending upon our requirement and depending upon the performance, we can choose any of the one. Okay, after converting the each line into some numerical vector with a dimension, we will store it in a vector database. This vector database can be anything. It can be It can be a normal vector database, or it can be a graphical database. Like this, it can be any of the one. This is vector database. We will store this numerical vector data of this text and store it in this vector DB. So if a user is asking a query means this query is also converted into some vectors, that means into some numerical vectors. Then these numerical vectors is compared with the text that present in vector DB, this vector DB. So this query, whenever a user is asking the query, we search the similar words that similar to this we will search the similar word that present in this vector DB that is similar to this user query. So we find this data that relevant to the user query, and we will mm, we will give that similar data to an LLM and not only this the data that retrieved from this vector DB is called as context. That similar data we retrieve from the vector DB is called as context, and this query also combined with this context, and this will provide to an LLM. So after providing these two data into an LLM, the LLM will provide some response to the end user, because this context just contain the words that similar to the user query. So to structure this user query in a human readable format, we provide this to LLM. This user query is called as prompt. Prompt. The context and prompt is given to the LLM. It will the LLM will read a context and the prompt and structure the context corresponding to the prompt, and we get the response. So in this process we retrieve some portion of data that present in vector DB, that portion of data that is similar to this numerical vector of user query. So to find the exact portion of data, we will use some kind of such technique. Mostly most of them algorithm uses vector dense search. Most of them like Fuzzy, and ChromaDB. ChromaDB uses this dense vector dense technique search to retrieve the exact data that relevant to the user query. In this dense search, we uses cosine similarity. We already know about what is cosine similarity. Cosine similarity uses the cosine similarity formula to retrieve the data. The context and prompt is given as an input to the LLM. The LLM will analyze and summarize and give the response. The final output will be in a form of in a summarized format that human can easily understand. Okay. So in some of the database, they will use hybrid search. Hybrid search. Hybrid search. Okay. This hybrid search is combination of multiple search technique. It's a combination of multiple search technique. Multiple search technique. Okay. In hybrid search, we use some multiple search like semantic search and then synthetic search. This synthetic search. Okay. We see that in an RAG model, RAG LLM model, the hybrid search is referred to a different search that combine together to that will retrieve the relevant document information. Okay, this is the main concept. Whenever instead of using this vector dense search, the hybrid search will more efficient and it will retrieve the more accurate and more relevant context from the vector DB. This is the big advantage of hybrid search when compared to any other search, because in hybrid search it does not only using a single search technique, it uses multiple search technique so that it can easily retrieve accurate and relevant data from the vector DB. Okay, in this hybrid search, the semantic search and synthetic search have been using. This semantic search uses dense retrieval. dense retrieval, and this synthetic search uses a sparse m- sparse matrix. Okay, let's see about synthetic search and how does it was working. Okay, in this in the synthetic search, in this method, in synthetic search method, we use a dense vector. Dense vector, that representation of a query and document. It uses some embedding. It's like it uses some embedding technique, like to these embeddings are created by using some models like BERT, BERT, and sentence transformer. This kind of these kind of models are used to retrieve the relevant data in dense retrieval, and it uses a bag of word to vec also, word to vec embedding technique also, to retrieve the relevant data. So it is semantic search. In synthetic search, it uses sparse matrix. It uses sparse matrix, like we have some traditional uh, techniques to retrieve information, like we use as before word to vec, we use as TF, IDF, and we also use one word encoding, sorry, one shot encoding, and bag of word. By using this kind of techniques, we will retrieve the we form a smart spark matrix, like like this is good. Let's take an example. This is good. When we apply small sparse matrix to this sentence, it will look like this. The biggest disadvantage of this sparse matrix is it will affect to it will affect to um, outliers, because of because of the zeros and ones. If this sparse marking present zeros and ones, if these zeros and ones are not in a normalized format, or when the zeros are so I when compared to one, or one is compared to uh, in a more number when compared to zero, means in these kind of scenarios, um, um, it will mostly affect. And because of outlier also, this semantic search will affect it. It will not get the information properly from a vector DB. So, but in dense vector search, it try to capture a similar data, that will similar to the keyword. The keyword is get from the user query, and a sparse matrix also retrieve a good information, but when compared to, it will extract a good information, but when compared to dense retrieval, it will get the information, relevant information. The accuracy is low when compared to dense vector, and it also the synthetic search will affect to the outliers. So there is but in dense vector, the retrieval is a little bit slow when compared to synthetic search, but accuracy of getting the retrieval data is good in dense vector search. So there is some advantage and disadvantage in both of them, and after that only the new technique is come to place, that is hybrid search. In this hybrid search, the context retrieval is so accurate when compared to both of them, because it uses combination of search technique. It uses both um, sparse and dense retrieval technique, so that the retrieval also fast and accuracy also is very good in this hybrid search. Advantage of hybrid search is it will improve the recall and precision. We know that recall and precision, and it will get the more more relevant context, and it also flexible. It can adapt to different type of queries, and hybrid search is a powerful tool in RAG model. It will enable them to handle a wide range of queries with a great accuracy. A big advantage of this hybrid search is it will get the it will retrieve the data with a greater accuracy and context. The context is so relevant, relevant to the user query. Okay. By seeing this diagram, you can easily understand how the RAG technique is working. How the RAG technique is working. First, a document is loaded, converted into some chunks, and then these chunks are vectorized by using some embedding technique, and this the embedded chunks, it's stored in vector db. Okay, stored in vector db. When a user is asking some question, the question is vectorized by using some embedding technique, and it will send it go to the vector db, and the relevant context the relevant context uh, the relevant context uh, the relevant context that similar to the question is retrieved from the vector db, and the context is next converted into some chunks and given to the llm, and this question is this prompt is given to this llm, and by using this both of context and the question, the llm will provide the relevant answer. It will generate the answer, summarized answer for the end user. Like this only, this drag technique is working. The hybrid search is working in this area to get the relevant context from the vector db. I think uh, I think after seeing this diagram, you can easily understand. Okay, uh, we can see more topic that relevant to generative AI in upcoming classes. Thank you.